second derivative. Like the end of class yesterday. We need to go back in our notes and figure out how to go past number 54. But first, in the back of your homework spirals, can you find me a second derivative?
Why can we not find 54?
Was potluck club today?
There was a comment. There was a comment in the class.
Was it potluck club?
Yeah. It was supposed to be Friday, so today was a little weird, like only some people brought stuff.
Mr. Kyle, he was the best. I saw Kyle in the
Do you have to bring food to eat the food in this club?
Supposed to. Some people donate money if we've like worked it out ahead of time. That's what we're bringing. This time, some people got messed up a little bit, so didn't quite work out. Huh?
Kyle should have, when he did his talent performance, he should have brought the waffle. Yeah, he should have started making.
And been like
just started flipping.
Making the waffle just because you'll be throwing them out in the crowd.
Waffles for everyone.
Kyle should become the next Miss Leon and sell his product.
Yeah.
I have a question.
Carbon dioxide for
If it's
everyone.
Y,
wait, are you guys taking a second derivative?
Yes.
at the moment, I was
Doing it now.
if it's
You need a
like
pencil, Sam?
just Y,
Yeah,
if
you-
it's
I
just
got you.
Y on the DX, so you don't write
It's technically one
I got it.
times CYDX.
Love that. I love more.
Tyler has a long pencil too.
I just got them!
Yeah. Guys, anyone else have pencil?
Yeah, I have pencils if you guys need them. Do you actually?
No, I know.
It
was a joke. Did you get it?
Hey, Eric, what?
My bad.
Yeah, Eric, why are you so snappy?
I don't know.
The waffle.
Yeah, it is. The syrup is kicking in.
Eric's mad at me.
Yeah, everyone watch out.
Yeah, I'm still salty about Mr. Strikes.
What was Mr. Stark's?
Wait, are you serious?
Yes.
The whole thing.
Wait,
Why did you have Tyler's?
Those waffles.
What?
Oh, really?
Oh,
Okay.
Oh!
Okay,
Because I was trying to do something nice, but she had to give me the cheese touch. I see how it is. I'll remember that.
I don't know half the class has no idea what's
I
They're just smiling and nodding.
You know, it's not like don't go on.
What am I gonna do?
The other day we asked Eric.
This one's
He thought he was like, what
What's
did you say?
You're
Come here.
Don't touch it! Don't touch it!
Eric, do you think the Bible test was hard?
Yeah.
Alright, I can start playing. We're just looking around anyway. Here we go.
My hand is like not wanting to like slap me.
That's valid. Am I gonna stomp you?
No.
Please don't.
Please.
You guys did prodigal, right?
Yeah.
Nope.
I just survived.
I did, don't worry.
So far, so good?
Add 4 over to the side.
Or,
I did.
And then 2xy plus x.
Derivative of 4x is 4.
Haha.
No, no.
So what did you guys do? Did you just keep going and take a second derivative, or did you move it first?
Move it.
Like that?
Just do that.
minus, oh, yeah, this one.
So if it just wanted the derivative, or it just wanted dy dx, we'd be done, right?
Yeah.
Now I think second derivative.
But it doesn't say first derivative, it doesn't say the derivative, it says second.
I know.
It's like flat, indented.
Do I get
You have both, right, Joe?
Yeah.
You're just waiting to check?
Yeah.
Alright.
So do you do quotient now?
Yep.
Just do it.
Unless you want to just do it and go this way and do a product
How do you do
rule.
that?
Okay, we can do
How do you do the product rule?
But if you want to make it pretty first, then we're doing quotient rule.
No.
But within the D top, do you have
Hey, you guys are the ones that chose quotient.
How do we do it the other?
I'm not. That's why I said product rule.
D top. Yeah, but that was a little while
That's
after
the same
everybody
thing.
said.
So why not?
You said make it look nice. So I made it look
I did not say make it look nice. I said do product rule.
Oh,
Yeah, that's
Said someone who has suspiciously a Matthew voice said make it look nice.
I did not
Bottom
say
D
that.
top. Oh no, D top! Is this what Tyler's talking about?
Oh.
It is 2x plus 2y.
So, second, D first. I'm going to bring that negative in so I don't forget. So, negative 2 plus first, but it's like a negative in there, right? D second, so D y dx. Bottom D top minus. Well, I decided to pull the negative into the box, Joe, so I went ahead and make that plus and made him a negative. So, second D first plus first D second. Derivative of y is dy dx, right? Minus top d bottom. Oh, that's just 2x. That's easier.
Priscilla's going crazy.
All over bottom squared. Telling you, it's in the waffles.
It is.
It's the cheese.
Okay, do we have bottom d top minus top d bottom all over bottom squared?
Yes.
That was very.
That's disgusting.
Or it was
so
a-
legit. What?
Can we box it and be done?
Yes.
Even worse with
We wish.
Wait.
Now, wait. If this was a long answer, then almost. What was the one thing you'd have? It's allowed to be messy. The messy isn't the problem. He's the problem.
Yeah. Just
Just
plug in.
plug
And
it
then have a
in.
bunch of things.
Who is he?
That's
4
the
plus
thing.
2xy.
Wait, what?
So if it was a long answer, we could make it or keep it messy. We just have to get it only with x's and y's. We would have to get it only with x's and y's. So I think distributing is probably a smart idea. That's true. So I'm going to go ahead and make it negative 2x squared y minus 2x cubed. But then I have to plug in that dy dx, which is 4 minus 2xy all over x squared. Oh, this might not be too bad. Just check it. I think my denominator is going to reduce, right?
I think so.
So then minus,
But it's still a lot of bunch of stuff.
yeah, it is. It is
8x
8x plus
Plus.
4x squared y all over x to the 4th.
You can't get out of one x. Maybe.
Now, hold on. If it was a long answer, what could we do now?
Just stop here.
Woo! Done! Why? Because we have the second derivative in terms of x's and y's.
Or if it's multiple choice.
If it's multiple choice, there's no way it's going to look like that.
Okay.
If it's multiple choice, there's no way. Okay.
Multiple down.
Oh, you can attack her. You did all that work to give her a water.
Why are you half off your seat and not grabbing your water bottle?
I tried to grab it, but she grabbed it.
Why do you have
Tell me
to
the
tell
story.
me the height?
Alright, so.
It makes sense, Misty. You just
What?
can't
Kidding. Oh, no.
Don't
I just can't accept that it's not high class.
Wait, can we schedule that and then go?
Yeah.
Now what? I believe I can pull out a negative 2x. What do you guys see?
Yeah.
Because I have a negative 2x at least, a negative 2x at least, a negative 2x at least, and a negative 2x at least, right?
Yeah, so you can just pull it out.
Okay. And then, wait, if I pull out a negative 2x, isn't the bottom going to become x cubed?
X3. Yeah.
It's just the air is like.
Okay,
it
thank you.
smells So weird.
That makes sense.
Wait, that's why. Well, negative 2x from the
I always
bottom.
keep sharp oil.
Yeah.
That's what I think.
Oh my.
The ice cream being cold.
Yeah. And he's like, can you just move us, please?
Don't I have an xy? And then don't I have a plus? Well, wait, I took those out, but then these are still here, right? So plus 4 minus 2xy plus 2x. I took away, 4x, right? Plus 4x. And then minus, careful, I took out a negative, minus 2xy. Whew, look at all those xy's I can combine. I see xy's. Did I mess me?
Yeah, there's 4 axes.
Yeah.
Yeah.
From
Why
the
is
tool.
that? Yeah.
Why is there?
Because it's 2x times 4.
Yeah.
That's negative.
No, the one next to it. Negative 2x in the front.
Yes.
That one.
I took it out though.
Okay.
And then I simplified the x with the x to the 4.
You only took out a negative.
No. Look. It's not x to the 4th anymore. It's x cubed. So I took out an x and I simplified. Why? Because that's what CalcChat's going to do. You're going to be like, yay, it's gone. And you're like, no, it's not. And yes, it is. Look.
That's how you make
My x came out and then it reduced
You took it out in previous.
in my head.
You're moving too fast.
Are you okay?
What?
Karma.
Matthew.
How come the negative 2x is still on the inside even if you pull it out? Shouldn't it be 4 minus y?
Just
No,
one.
no, no. I took out this 2x, which came from both of these. So these stayed exactly the same.
Makes my brain.
I have to do this the long way. All right, I'll do it the long way.
Like one.
I understand you distributed it, but I just don't. Text.
I could make some trash.
Yeah, that's perfect.
Perfect.
Is it a bug or what's going on?
There's a spot in
What did I do? I decided to, because Matthew was stuck up here, I decided to distribute. I was trying to avoid that step to save time, but that's all right. I distributed. Then what did I do? Then I pulled out my negative 2x. I wrote it so that you all could see it. Then I simplified the x with the x cubed. This is what I had a second ago, and it's still just as right as it was before, but I have all the steps written out as to how. Now, if you can get to where you're skipping some of these, life gets so much easier. But if not, oh well, it is what it is. But guys, there's no way we're done. Because look, there's 1xy minus 2xy minus 2xy. Wouldn't that be minus 3xy?
Yeah.
And then I have 8, so I have 8 minus 3xy times a negative 2 all over x cubed. Are we tracking? Now, could they do one of those magical math things where it looks way different at the next step and they box it and be done? What would they be doing if they did? Looking way up there and saying, hey, can I plug in? But does x squared y minus 4x match anything down here? No. So it's impossible. They can't just plug in 5 for something that's crazy because that's not present. Now, what was true in the one that we did at the end of class yesterday? At the very end of, oh, sorry, your notes didn't say yesterday. I have no idea why. That's not going to help. But yeah, look at the last example we ended on. Wasn't there an x cubed plus y cubed? That became 1, and you're like, what? That's not, oh, that is a thing. It wasn't that problem because you started with x cubed plus y cubed. It's just an idea, just something to keep in the back of your mind. When you solve 4-second derivatives, if it magically just looks so different, not like they factored, not like they reduced, not like they combined like terms, not like they simplified a denominator, but just it disappears, you've got to look back up here and say, wait a minute, could they have plugged in 5, 4? Oh no, they couldn't, because there's nothing there that matches, so forget that. Okay, whew, that was the homework file. Let's get back into our notes. This is what I tried to teach on the whiteboard until I had to go off and do a new team thing with search and rescue and the earthquake drill. And this is what would help you finish homework for section 2.5. Finish? Weren't we supposed to finish for today? No, what did I say in the comments?
Question 54.
Only up to 54. Only up through 54, which means, oh, we just forget the rest of homework? No, you have to know how to do it. You just didn't need to stress about learning it by yourself last night. Because I'm going to show you now. So, what if you already submitted your pictures? Good. That's what you were supposed to do. You only have to go through number 54. So then finish the rest of the homework tonight. That way you can have it ready for when you turn it in for the test and everything should be done. What if you didn't submit because you were, oh wait, PSAT. No, you guys were all in class yesterday. We talked about this. But if for some reason you didn't submit and you're submitting it late, well, you better have it all done. So get it all done before you submit if you haven't submitted it yet. Sound good? Okay. So wait, is anyone just randomly skipping this and saying it's not important? No! But some of you were able to submit homework early. You're just finishing it up as you can. Okay. So logarithmic differentiation. What? Did anybody go looking at number 63 to see what you were skipping, or were you like, oh no, thank goodness I'm done? The title of the section would have been logarithmic differentiation. Wait a minute. Some people told me when we were sitting out just chilling and bonding before I knew I was supposed to go somewhere, on the earthquake drill 30-yard line, they were like, it got hard before number 54. I was like, what? And they're like, yeah. How do you do ln of y? And I said, you use the ln rule. How do you derive ln of y? Or they were confused with e to the y. And I was like, just use the rule. For instance, which rule is literally on the wall right now? Okay, well not e to the y, e to the u. But that's okay. The derivative of, if you have to take this guy's derivative, don't you just follow the rule? It says the derivative of e to the is e to the, whatever it is, times u prime is dy dx. That's it. Okay, but wait. ln, he's way harder, right? No, he has a rule too. 1 over u times u. Why am I showing you that? Well, in just a second, if we're doing something called logarithmic differentiation, do you think we need to know how to take a derivative of a log? Especially the nicest, easiest one? Oh, sorry, that's annoying somebody. I don't know if this class is. I'll stop tapping. It's just so hard when I'm like, okay, let's go. Anyway. But wait a minute, why would I be using log properties? There is no log. Look at it. There's a tangent, an x squared, there's a cubed root, there's a y. Why would we be doing a log? Pencils down. What if we were finding the derivative the old-fashioned way?
The chain rule.
What I mean by old-fashioned is before this.
Just go.
Yeah. Tyler, just go for it. Which means dy dx is equal to, ooh, I don't think I want to think of that as a cubed root. I think I want to think about that as a 1/3 power, right? What do we do to a 1/3 power? Pop it down. What do we do to the inside? Keep it. What do we do to the outside? Negative 2/3. Woo, careful.
1/3.
Right? 1/3 minus 3/3 is negative 2/3. Why am I putting it times?
Because there's
Who's
something
on the inside? Derivative of 2.
0.
Derivative of
Secant squared.
Of what?
X squared.
Square.
X squared.
X squared.
Why is there another times?
Because there's something in the
Times
tangent.
2.
You're done.
Yeah, it's 2x.
Woo!
You're done.
Okay. But was there another way? Pause. Write down the old-fashioned way. Old-fashioned, just go for it. Take a derivative. Old-fashioned, just go for it. Take a derivative. Double check that you understand how I did the derivative the old-fashioned way. Which really just means as is. I just took the derivative as is. Kind of like, I don't know, you could say I'm inspired by implicit differentiation. You just go for it as it is. You don't change it, you don't rewrite it, you just, well, we rewrote the cubed root to be a 1/3, but we went for it as it was given to us. Logarithmic differentiation says, no. Throw in a log. What? We hated logs in pre-cal. Why would we ever bring a log into a problem if it's not already there? Huh. Gavin, this is your question.
It says secant x squared and 2x. Are those like are the same thing? Right at the end. I'm not exactly
I have a lump. I have a lump times a lump times a lump. I have a y prime, u prime, v prime. Or I should say f prime, u prime, v prime. I did it power rule first. Times 0 plus, I did a secant squared next. I did a 2x last. Outer. All the little. So I had cubed root, then 2 plus tangent, and then x squared. Okay. Why would you ever bring in a log if it wasn't there before? Why am I going back to black?
You're not done with this.
I haven't derived it yet. I'm starting over again. Except instead of this time going for it, okay, we rewrote the cubed root. What I mean is, I'm about to change the whole game. If I put an ln in, am I allowed to do the same thing to both sides? Yeah. Algebra. What could that do? You can use log properties. As long as there's a log, there's not. So we put one in order to simplify before deriving. What cool log property lets me deal with this without taking a derivative?
Put it down.
And that's still black, not red, because I'm not deriving. I'm just rewriting. I just have one less chain rule to do. Now, hold on. That ln needs to be on the other side. So if we have to take a derivative, wouldn't we have to go for it as is?
Over y.
I couldn't show you how to do this before to simplify nasty chain rules and product rules and quotient rules because you didn't know implicit differentiation yet. But now you do. How do we derive ln of y? We just talked about it. 1 over y times dy dx. And what's over here? So 1/3 is just a coefficient. Ow! Now I have ln of u. Well, how do I derive ln of u?
ln of u 1 over u times u prime.
Times u prime. What's u prime? Oh, I have to take the derivative of 2 plus tangent of x squared. Well, didn't we just do that?
Yeah.
Okay, so we still have to think through some of the math if it doesn't simplify all the way. But that's not the same thing. I'm not done yet. Who is still not quite alone?
dy dx.
So guess what I'm going to do? Multiply times y. What I do on one side, had to do on the other side. But, wait a minute, did this answer have y's in it or just x's in it? So how could we make it just have x's? Remember how we would plug in dy dx? We can plug in just y. If we need to make it match, if we need to have it just in terms of x. And what we end up with is dy dx is equal to 2x secant squared x squared all over 3 times, wait a minute, who is y? Y is the cubed root of 2 plus tangent x squared. Hold on, I have one of those down there. So I have a 1/3 up here power and a 1 down there. What's 1/3 minus 1? Because when you have like bases, you subtract. Oh, so it's going to be 2 plus tangent of x squared. The negative, oh, no, it's down there. So the 2/3. Guess what? Well, the negative pops it down. So it's already done, so I don't keep it.
Oh, yeah.
Now, long story short, the point of this problem was not to show you that using ln makes everything easier, because to be honest, it didn't make everything easier. We still had to take the derivative of tangent, derivative of the inside. We had 3 different, okay. But you did at least see if there's not an ln, we can put an ln, and maybe we can use some ln properties before we take derivatives. We just have to be careful. If we put an ln in over here, all of a sudden it's implicit. We have to get dy dx by itself by multiplication, and maybe we have to get even the y out of there before we finish. But to be honest, wasn't there only one long property this time that we got to use? And there was still nasty stuff inside? What if our problem was a little bit different?
What is this?
On a page before, you might be like, ln didn't really help. Didn't really make it easier.
I don't like that.
How would you have to take this derivative right now?
Okay.
Do you want to put pencils down? I'll do it. I'll do it the old-fashioned way. Okay? But I'm going to add a page. You don't have to do it. I'm not even going to make you write the old-fashioned way. Like, I don't even want you to do it the old-fashioned way. I'm going to show you how you could. Ready? Okay. You tell me quotient rule.
So,
Okay. Okay. I'm going to have to take some time on this, right? Because I have bottom.
Should you write that as one?
I need D top, right?
Yeah.
I can't. I'm not going to.
And there's
D top. I have a product rule, right?
So,
Second,
x minus 1.
D first plus first, D second, which isn't going to be too bad because there's not a chain rule. It could have been a lot worse. Could have been times another U prime. That's second D first plus first D second. Got it. Minus.
Second.
That was just bottom D top.
top D bottom.
Okay. So top
The same thing.
D bottom would be.
The whole thing to a negative. Yeah. Negative.
I have to bring down the 1/2 and make it a negative 1/2 power, and then don't forget my U prime. Okay. All over bottom squared.
That's just
Okay, yeah.
Yeah, I just skipped it.
I mean, thanks guys, that helps. Do I have some work to do?
Yes. A lot.
And was there a lot of math that I had to do kind of mental math style in that? Yeah. So why? Oh, why? Oh, why? Look at that derivative. Bask in the disgustingness. And then come back over here. Why would we ever bring an ln into a problem? Remember those cool properties of ln's, like ln of a over b is ln of a minus ln of b? Quotient rule becomes subtraction? Yes,
What?
please. Or isn't there one where ln of A times B becomes ln of A plus ln of B? Product rule becomes addition? Check it. Ready? Rewrite. See if you can understand why I can rewrite this to be ln of x plus 3 halves ln of x minus 1 minus 1 half ln of x plus 1. Pause. What did need this is now just addition and subtraction. Because it was an A times, no. It was an A times B that could be split up. What happened to the, don't those get to come down with ln's?
It does make sense.
And then there was an ln of A over, there was an over, so I needed a minus of this guy. But wait, where's the square root? It's a 1/2 power. Ah. Can I take his derivative instead of his derivative?
Maybe.
Definitely. All I did was rewrite, and rewriting is totally legal. Now check it. 1 over y times dy dx. You guys see why I took time to talk about this guy? What's his derivative? 1 over x times 1. 3 halves times, it's a coefficient. 1 over u times u prime. That's just 1. Minus 1/2 times 1 over u times u prime. Oh, that's just 1. Now be careful. The times and the minuses, that's a minus, that's an n. Careful. But check it. Can't I just say, wait, where did the 1 over y go? I gotta get dy dx by itself. So I have to move him to the other side. So I multiply him over here. Now what do I have? 1 over x plus 3 over 2 times x minus 1 minus 1 over 2 times x plus 1. Done! Wouldn't this have all been in terms of the derivative, only been in terms of x? So what do I need to do to finish? So the nice thing is, if the AP ever asks you to do logarithmic differentiation, they'll have you go here and then stop. Which is nice. You don't need to make it match the explicit form, which some of you struggled with in homework. Because they said, do it implicitly, do it explicitly, and make sure they both work. And you're like, but I thought implicit was easier. Why would I do it the hard way? They're just trying to show you the difference, but also how they both work. If we would want to make this, which is the answer, look like this, wouldn't we have to get common denominators, mush it all together, then mush it all together, and then compare? But we don't have to. We just get to stop right there and say, that's the one thing.
Fortunately, it's not multiple.
What was easier for your brain? Quotient rule with product rules with chain rules? Or derivative?
If it's for multiple
Right?
choice, the right side.
If it was multiple choice. Oh, Joe's thinking if you have to make it match. But here's the dealio, Joe. If it was multiple choice and they say logarithmic differentiation, the answers won't look like that. They'll look like
Okay, then just the left side.
that. If they don't say logarithmic differentiation, then I agree with Joe. You would probably want to go this way because then it ends up in the nice condensed all-together version without having to do extra work. But this is so much easier on your brain. If they say logarithmic differentiation, man, go for it. Guess what problem number 60, oh, what was the next one on homework? 61, 63? The one that we didn't do? 60-something? The next one?
Yeah.
63? Guess what the directions say? Logarithmic differentiation, aka put in the ln's, take a derivative after splitting apart as much as you can. Plug in y, multiply y, plug in y, be done. Fill in, dun, dun, dun. Okay, that brings us up to section 2.5 homework that you were supposed to have attempted for today. Oh, who's this guy?
Not me.
Wait, is that a power rule? Is that a B to the U?
What is this?
What is that?
You can actually split it up.
Is this like a, where you have to make the bases match or something?
Find the derivative using algebra to make the change.
Is it one of these? Yes or no?
Yes. Wait. No, there's an X on the top. There's a
Is it
variable
power
on top.
rule only for when you have a constant like x to the
There's
fifth
no
or x to the
constant.
1/2 or x to the 2/3 or x to the 17th? Isn't power rule only when n's are constants?
Yeah, it is some sort of number.
So why do I have to say nope?
Because this one has an X.
This one has an x. Oh, that doesn't work. Oh! I got it. This is a b to the u, right?
No.
Not really.
Why not?
Yes.
There's a u up there. 3 plus x. It's a u.
No, it's not.
3.
Because
What
there's
is?
2x. There's a variable on the bottom, too.
Oh. Because in this one, what does b need to be?
B needs to be a constant.
Oh, and I
Some
don't
sort of number.
have a number, I have an x, and I don't have a number, I have a 3 plus x.
Let's just give it up and move to
E is a constant too.
Could you do that one?
Can we just actually split it?
The only legal way to do this problem, the only legal way to do this problem is to say, I can't handle you until you come down. Literally, you can't handle it. None of the rules work until you bring it down, and here's the problem. Can you just bring it down right now?
Not really.
Why not? Well, no, but your brain will say yes. Why? Oh, it's the power. Bring it down.
It's not one term.
Is
Some-
it the whole thing? I know. Is it the whole thing's power? Or there was no parentheses. It was just the x.
So you have to put the ln in
Two.
between.
Like a ln on the
Yeah,
two
2
and
ln
ln.
something.
2.
Oh, you want to do it that way? You can do it that
Yeah.
way. You want to split it up?
ln.
Two
2
times,
ln.
right?
2 ln.
No, not 2
Yeah.
ln.
And 2 plus.
You can
Bye,
do something.
Tony.
Good luck.
Rectus.
Now can I bring down 3 plus x?
Maybe.
Yes. Ln of a base to a power. I had to split the 2 up. Now, you could divide the 2 right away. Or you could say, wait a minute, I can split them up. Haha. There's a property for that. Sorry. Oh, okay. I don't know how that habit started. I can now bring down the 3. Why am I using black, though? I thought we were supposed to be taking derivatives.
Just rewrite.
I have not even started deriving. I'm just rewriting. Did you hear me say a second ago you couldn't handle it before you took ln on both sides? Because there's no rule that legally lets you take that derivative without ln, which means you can't handle it until you take ln. Just making sure you realize that's the only way to go. But why is my red pen out? What'd you say, Tyler?
Now you do it.
I like it. Look at this blank button.
We should have.
What'd she
So
say?
you can't handle it until you calm down.
We should have a
Until you bring it
Starburst
down a
dash. And everyone say something meaningful. You just go Starburst.
Why are we talking about me? I don't understand. What's the derivative of ln of 2? Oh, it's 1 over u. 1 over 2 times 2 prime. Wait, what's 2 prime?
Just
Oh, it's a constant.
0.
That's the
It's
error.
gone.
And then, sorry, no other option.
Yeah,
Second,
It's better than the previous.
d first. Oh, that's just 1. Plus first.
D second.
Don't forget parentheses. D second. How do we finish this off?
Move it.
Move what?
Bye.
There you go. So dy dx is going to equal ln of x plus 3 plus x all over x times y. Wait, do we stop?
No.
Because who is this?
2x.
The thing.
Yeah.
That you can't really
Until you calm down. There we go. Oh, but all I have to do is put that there, right? Dun, dun, dun. Okay, hold on. Rewrite it.
What? Oh, the one. Sorry, I was just like, where did the 2x come back?
It looks magical. But it was just going back to the beginning and plugging in. Woo! Section 2.5, you can go all the way through the end. Now. This morning I told period 1, I was like, what are you going to miss today? You're going to miss them getting to practice the second derivative, what we eventually got done at the beginning of class. What else are you going to miss? Me talking through every single step of this whole logarithm differentiation. They got a very shortcut whiteboard version where I worked out this problem for them, wherever he is, and asked how it was done. Or maybe I worked out this one. I don't remember. I worked out one of them. And then I said, you're going to miss grading. Boop, here we go. Section 2.5, all the way up through 54, and you're finishing 63 through the end tonight. And we'll grade those evens tomorrow. But let's see how you did on the non-logarithmic differentiation stuff. Because you have to make it match.
For the homework, we were just submitted and.
No. If you submitted up through 54, you're good. Just for tomorrow, have the rest ready to grade.
Oh, okay.
But no extra submission.
Okay.
No extra submission. Welcome. Bye, guys. Number 4. Did you get the final, or can you make it match with negative 2x squared over 3y squared? Did you guys kill poor little kittens and just like disappear the squares? Don't do that. Good. Number 10. Ooh, did you get the e to the? What's the derivative of e to the u? E to the u times. What? It's a product rule. Oh yeah, x times y. Second d first, let's first d second. Oh.
So annoying.
Product rule.
So
Number 10, if you got it wrong, write down the final answer to try to make it match tonight and go back and try again. But tell yourself, ooh, he's a product rule. E to the u times product rule. U prime. U prime. Number 18. Woo. They got a common denominator and pulled out a negative. Oh, that's not nice. They got a common denominator and wait a minute, how did they? I thought it was 1 over u times u prime. What did they do? Rewrote and then took the derivative. Maybe you did it a harder way. Maybe you did it a harder way. ln of x times y. You could check it. You could rewrite and maybe make it a little bit easier on yourself. Matthew, what's up?
How come for some problems they use dy over dx and then others they just use y prime?
Have you seen it yet?
Yeah.
Here?
Yeah. What about that?
Same thing.
Okay.
My guess is, oh no, that doesn't make sense. I always do dy dx because in my work, the prime sometimes gets lost and I don't see it, and so I make mistakes. Same reason some of you guys like h better than delta x. Those of you that liked h better, you better go with dy dx. It keeps it totally separate. Those of you that liked delta x with x, you didn't mind, maybe y prime is okay. Just be careful. They're showing you both of them technically are equal notations. But I think this one's more dangerous and this one's a bit safer. Good question though. Thanks, Matthew. Oh, they were final answer. Number 22. E to the u times u prime, which was the foundation of, and we just looked at that one. Maybe you didn't know it last night. That's the foundation of y. Uh-oh. Product rule. Are you finding all the product rules? Product rule. Derivative 4 is 0. Move it to the other side. So far, if you guys haven't noticed, they've been leaving all the derivatives with x's and y's, which is nice. You get to kind of leave it. As soon as you get dy dx by itself, you're good. 28. They're just using that y prime, but guys, what could you have written instead? Yeah, totally fine. Totally fine. Totally fine. Oh, but you weren't done until you plugged in the x and the y to get the point. Or I should say the slope. Oh, you got 3?
Oh, no. Sorry, I just don't know how to do 4 over 12.
There you go. Oh, yeah, your brain. I got it. Number 54. had to go to the second derivative. How did you? Wait, how did they go for it? I don't see a quotient rule. I see them just going for it from up there, little stinkers. But could you have done a quotient rule? Yes. And should you have gotten to the exact same place? Yes.
Oh, okay.
They went, remember, you can rewrite it, make it nice and pretty, and take a derivative quotient rule. You should have ended in the same place, but they decided to come back here and say, nah, I'd rather product rule it. Now wait, if they're showing y double prime, isn't that d squared y over dx squared? Guys, I didn't just give you an even for second derivative, right? I gave you an odd. That way you can look at CalcChat. I don't know if it was a video or not. That way you can look at CalcChat and check the answer in the back of the book. This is as far as you were supposed to get last night, getting up to the second derivative. But were there a couple places where, like with e to the u, maybe you weren't quite ready for it? Or that one ln one? Maybe you didn't realize, hey, I can split it up. Tonight, keep going. 53 and beyond.
Maybe the answer for this
Yeah. There you go. 54 is done implicitly and explicitly. Bye, guys. It's the sauce that I use for
I know, literally it's Tyler. That was so funny.
Two violence.
You don't need to do. Just have it ready for tomorrow for spring.
This is my.
A friend who has worked in Chicago his entire life tells me it's not that violent.
State of violence.
Oh my goodness. That's awful.
Bye.